Okay, everyone, I hope screen is visible to you.
Yes, sir.
Yes, excellent. Okay, we'll just continue our discussion on system of particles and rotational motion. If my voice is very low, let me know. I will just raise my voice. Is it clear now?
Yes, sir.
Okay, right. Great. I think the first worksheet which was given to you contained 30 questions, right? Good, Shamita, welcome. Good, Meda. Yes, Alvin has come. Good, welcome. Okay. So I think the first worksheet has your questions till 30. Am I right? Okay, now we'll be starting from 31. Is there a voice delay, guys?
Sir?
Is there any voice delay? Is it clear?
Yes, sir. It's clear.
Okay, okay. If there's any difficulty, just let me know. Okay. So we'll continue from the
Yes, sir.
31st question. Okay. Okay. Now can you guys tell me? We're going to see some concept-based questions as well as simple formula-based questions for your CET now. Okay. I think we are completed till 25 or 26. I'm not sure. Can you check and tell me in the previous worksheet?
25, sir.
Yeah, okay. So 26 to 30, you please attempt it on your own. And if there are some difficulties, then I will discuss them as well. Now from 31, we are going to discuss. It's not given in the worksheet for you, but it's going to be here in the PowerPoint. Okay. Later, I'll be sending you the questions separately. Okay, everyone? Okay, let's look into the questions now. A rigid body is that which does not change its dash after application of force. When do you say a body is rigid?
The body does not change its size or shape even after force is applied, sir.
Yes, yes, that's correct, Shamita. Right? A rigid body is one which does not change its shape and size. Perfect. Okay, that's the right answer. If you remember, I had demonstrated this using duster and also something which is somebody's purse. I had taken and I mean the uh, pencil box or something. I was just applying some force, and you could see the positions were changing. Correct.
Yes.
Okay. Now let's move on to the next question. A straight line around which a rigid body is rotating is called.
Axis of rotation.
Absolutely. Yes. That's called as axis of rotation. That's the technical term for that line about which a particle is going to rotate. Okay. Let's move on to the next question. So when there is no external force acting on the system, then what will happen to the velocity of the center of mass?
constant, sir.
It will be constant. Yes, that's correct, Rahil. Because can you tell me why?
Law of angular conservation of angular moment.
Law of conservation of linear momentum only, Rahil.
Yes.
Because when external force is not applied, then what happens is your acceleration is not there. Because of that, center of mass will have the same velocity. So constant is correct.
Yes.
Yes, good. Next question. In a pure dash motion, all the particles of the body experience the same linear displacement as any other particle.
Translatory.
Absolutely. Right. In while we introduced rotational motion, I was talking to you guys. That's the reason displacement, velocity, all that is important in translatory motion because if let's say there are four people in a car and the car is moving in a straight line, if the car has covered 10 kilometers linear displacement, then every person, the driver, the one who is sitting next to the driver, the people on the back seats, all of them have traveled 30 kilometers. Is it not?
Yes.
Absolutely. Therefore, translatory motion, pure translatory motion, all the particles of the body experience the same linear displacement as any other particle. That's correct. In a pure dash motion, all the particles move in circular paths. All the particles move in circular paths.
Rotatory, sir.
Yes, Rahil?
Okay.
Is it
Option
rotatory
A.
or circular?
Uh, circular, sir.
It is
Sir,
rotatory,
no,
Rahil.
sir. Option A only. It's
Option A
option
only.
A only.
Rotatory only. Why? Because in a circular
Axis of
motion,
rotation.
one particle undergoes circular motion, right? When you say rotatory motion, it's for the entire body. Every particle in the body undergoes circular motion about an axis, a straight line called axis of rotation. So it is, so here itself you are given the hint, right? Axis of rotation.
Rotation.
It's a rotatory motion. Okay, first option is correct. Okay, guys, let's go to the next question. Yes, can you guys tell me? Read the question. A body traveling in a parabolic path under the influence of center of gravity explodes in midair. The center of mass of the fragments will. Have you understood the question?
So option D, sir.
Option D is correct. Can you explain your answer, Rahil?
Sir, like I don't know how to explain, sir, but I know it's option D.
Okay. See, a body is traveling in a parabolic path. Now it explodes in midair. This explosion is because of external force or internal force.
External
Inter
force. Sir.
See here, you know how
internal
an atom
internal
bomb.
force?
Yes, everybody? Everybody? Anybody else?
Internal force?
How do you say that, Emmanuel?
Because it's exploding, that means it's not collapsing into itself, it's going outward. So it has to be from inside,
Right,
something
right,
pushing it.
right, right, Emmanuel. If you see, say nuclear fusion happens, you get what I'm saying on nuclear fission, depending on those reactions, right? You're going to have a bomb explosion, right? Now, what is it? It is all
Yes.
internal energy. See, all those chain reactions, I think you have learned, correct? It is because of internal forces, no external force, all right? So what happens is, the point I'm trying to make here is, because the external force acting is zero, you can apply law of conservation of linear momentum, which means your center of mass velocity will not alter, which means the center of mass will still follow even after the explosion. Even after the explosion, let's say they are being into, they are the particles, let's say the bomb splits up into four pieces, for example, and the four pieces are going in all possible directions. If you do the center of mass for all those four particles at any point in time, that position of center of mass will be following the original path of the bomb. Are you able to understand what I'm saying? The bomb is not going in the original path after explosion. I hope it's clear to you. But the center of mass of the exploded parts. Should I explain again? Is it clear? Is my voice clear?
Yes, sir. Yes, understood.
Yes,
Understood.
sir.
Could you come? Could you reframe it or reiterate it, Rahil?
Sir, so when a body is thrown, sir, and it explodes due to internal force, sir. So no external force acts on it. So we can use the law of conservation of momentum, and with that we can say that the center of mass follows the same path as, like, what to say, the unexploded bomb.
Yes, yes, absolutely. The center of mass of the exploded part also, because all the exploded parts, if you trace the center of mass, that will track the original path. Yes, right. Okay, great. So that's the fourth option. So we'll move on to the next question. It's a straightforward question.
Minus k cap.
Yes, that's absolutely right. Okay. Because we know I cap cross j cap. That's I cap refers to unit vector along x axis. J cap refers to unit vector along y axis. So when you do cross product of both, you will get a vector which is perpendicular to both these vectors. So that represents z axis. But whether it's k or minus k depends on the order. I think we have learned I cross j gives you k. J cross I will give you minus k. So the answer for the correct answer for this question is option C. Clear, everyone?
Yes, sir.
Yes, sir.
Excellent. We'll move on. The linear and angular velocity of a body in rotatory motion are given. Linear velocity small v is 3 meter per second, and omega, the angular velocity, is 6 radians per second. Linear acceleration is given a, which is 6 meter per second square. Then what is alpha? Right? Options are given. Now, can you tell me the relationship between R and, I'm sorry, V and omega, linear velocity and angular velocity?
V equal to R omega.
Who is that? Devraj? Did you answer that?
Yes, sir.
Very good, Devraj. That's fantastic. V is equal to R omega is correct. Please, everybody note down. V is equal to R omega. That's the relationship between V and omega, where R is the radius of the rotating part. Okay, from that equation, what can you find out?
R, sir.
R. What is the value of R you're getting?
2.
V is equal to R omega. So R is omega by V. So you're getting it as
1 by 2.
yes, 1 by 2 meter, right? Okay. And linear acceleration is given. Alpha is given. Alpha is 6 meter per second square. Angular acceleration is asked. What is the relationship between linear acceleration and angular acceleration? Anybody? Yes, guys, come on. See here, V is equal to R omega is known, correct? Differentiate it once on both sides.
A is equals to R alpha.
That's all. A is equal to R alpha. Please write down, guys. Linear acceleration A is equal to radius times angular acceleration, R alpha. So what is your alpha?
12.
Yes, yes, ma, that's correct. So we get, using V is equal to R omega, we get R is equal to half. By using A is equal to R alpha, we get alpha is equal to 12. Therefore, the right answer for this question is the third option. Is it clear, everyone?
Yes, sir.
Excellent.
Yes, sir.
Excellent. Okay, let's go to the next question. Okay. So a force F, which is equal to 4 I cap plus 2 j cap minus k cap Newton, acts on a body at a distance of q vector is equal to minus I cap minus 3 j cap plus 4 k cap from the origin of an inertial frame of reference. Find the torque acting on the body. Anybody can tell me the relationship between torque, the position vector, of a point, which is here given as OQ vector. If O is the origin, I can call it as R vector also. And F vector is the force. So anybody
R
remembers?
vector into F vector.
Yes, Devraj. Okay. Torque is equal to, you shouldn't say R vector into F vector, but R vector cross F vector.
Oh.
Good.
Yes, sir.
Okay. Okay. So what, anybody can tell me the method, how we can get the answer for this?
Determinant.
Fantastic, Rahil. So determinant in the first row, what should be there, Rahil? Or anybody?
I, J, and K.
IJK.
I, J, K. Absolutely. Second row,
Sir, we have tried the coefficients of F and then
first which one? Second row, what should be there?
R, sir.
R vector, right? So first you should write. So second row, what you should write?
Coefficients of R vector. Here, Q vector.
Yes. So -1, -3, 1. And finally, last, the coefficients of I cap, J cap, K cap in F vector. So that will be 4 to 1, -1. And then in the class, I've taught you how you can do the determinant method. Please try it. I hope we did this in the class. Yes?
Yes, sir.
Yes, Mehta. Now, how do you do this? I cap, then you will cancel that first column, first row, then what? Multiply these two. -3 into -1 is 3, 3 minus 2. Minus J cap into -1 minus 4. Plus K cap into -2 plus 2 plus 12.
So, I cap plus 3 J cap plus 10 K cap.
Yes. So which of the options is correct, Rahil? I'll show you the options once again. So it's already, I have marked it for you. Isn't it the first option?
Option is
Yes.
yes.
I'll give some time for everybody to note it down. Then I will also give you a technique where you can find the answer without doing this. Okay. By using a different logic. But only you can do it with the options. How you can answer from the options. Have you all taken down?
Yes.
Yes. Okay. Okay. Now I'm going to tell you a technique for answering this sum very quickly without having to do this determinants. Okay. Fine. Now one thing you know, that's also from the concept. Okay. If you have A vector and if you have B vector, then can you tell me the direction of A vector cross B vector?
Sir, can you repeat, sir?
I'll repeat the question. If you have A vector given to you and if you have B vector given to you, then you do A cross B, A vector cross B vector, right? For example,
Yes,
in
sir.
this case, torque vector is R vector cross F vector, correct?
Yes. Yes.
Yes. Now, if R vector is going to be, I'm sorry, so A cross
Perpendicular
B.
to
Yes, tell me.
it's going to be perpendicular to the plane of A cross A and A vector and B vector.
Very good, Rahil. Yes. So we have seen that A cross B is a vector which is perpendicular to both A and B. Very good. Or it's going to be perpendicular to the plane of A and B. Right. Very good. So if two vectors are perpendicular, then what can you say about their dot product?
It will be perpendicular to both of them.
No. My question is this. Yeah, I understand the definition of cross product. Okay, I understand that you get it, right? My question is, forget cross product or anything now. If two vectors, let's say x and y, are perpendicular to each other, then what property you know about them in terms of vectors?
Like they'll be in the diagonal. of the
The moment I say perpendicular, I've told you sometimes, you must immediately tell this, right? If two vectors x and y are perpendicular, then x vector dot y vector is 0.
Yes.
Why? Why is it so?
So because cos 90 is 0.
Yes, absolutely, Meda, right? Because x vector dot y vector is nothing but xy cos theta. So theta is 90 between them, therefore you will get xy cos theta is 0, correct?
Yes, sir.
Yes. Okay, so
Yes.
A cross B is a vector which is perpendicular to both A and B. Therefore, if the answer, if you dot it with A or B, then you will get 0, right?
Yes, sir.
So you have your F vector, you have your R vector here. What is provided in the four options is what? R cross F, correct? Yes or no?
Sir, I
Yes.
didn't get it. Tell again, sir.
Listen carefully. R vector is given to you, that is in terms of, here it is given as Q. F vector is given to you. You are asked to find torque. Torque is nothing but R vector cross F vector, correct?
Yes, sir.
Yeah. So the answers, four options which are given here are nothing but torque, correct?
Yes, sir.
Which is nothing but R vector cross F vector, correct?
Yes, sir.
So what can you say about this answer, R vector cross F vector? Wouldn't it be perpendicular to R vector and F vector?
Yes, sir.
Yes. So if two vectors are perpendicular, what can you say?
The dot product is 0.
Yes, their dot product is 0. So if you dot your answer with F as well as with R, the answer you must get is what?
0.
Yes. So now see here. What is F vector? Can you tell me?
4i cap plus 2j cap minus k cap.
Right. What is your answer? Let's take the first option and check. What is the first answer?
I cap plus 3j cap plus 10 k cap.
Right. Now you check the dot product of the answer with F vector. How do you check the dot product? Dot product.
F is positive. F into the answer.
For that you need theta. For another you need theta, Rahil. When ijk is given, nothing, and it's very simple, right? Dot product. How do you find of two vectors? You're on mute, Rahil.
So like I cap with I cap and J cap with J cap.
That's all, right? So what do you get if you do dot product of the answer with a f vector? Tell me how you multiply.
1.
What are the coefficients of answer? Tell me.
1 plus 3 and plus 10.
Yes. What about the question? What about f vector?
4
plus
plus
2 and
2
minus
minus
1.
1.
What you should do when you do dot product of two vectors, multiply the coefficient of I with coefficient of that next vector, plus coefficient of j with coefficient of j of the other one, plus, correct or not?
Yes.
Yeah, do it now, guys. You must remember that. Okay, it's very
It is 0.
yeah, 1 into, tell me, Rahil, tell me how you are multiplying so that everybody understands.
So it will be 4 plus 6 minus
No,
10.
go step by step. They don't know how it is 4.
Okay. So I cap and I cap, so 4 into 1.
Yes.
So it will be 4. Plus 2 into 3, it will be 6. And minus 1 into 10, so minus 10. It will
Yeah.
be 4 plus 6 minus 10. So 10 minus 10 will be 0.
Yeah, exactly. So you are doing a dot product of your answer with F vector now. That is 0. Do the dot product of answer with Q vector now. Tell me now, Meda.
-1
Hmm.
into +1 is -1.
Yes.
-3 into +3 is -9, so -10.
Yeah.
Then +10 into 1, that is +10. -10 +10, 0.
Excellent. Excellent. Okay. This is what you can do. This, when you do it, it will take very less time.
So, yes, sir.
Okay. No, but you should know the idea and dot product of how to do all that should be in fingertips. Okay.
Yes, sir.
Fine. Okay, folks. This was a technique which I wanted to teach you. Okay. Of course, the regular method is doing the determinant. Okay, folks. We'll move on. We'll go to the next question. A straightforward question. Okay, angular acceleration is given by which of these expressions is correct? It's also very simple.
Option A.
Yeah, can you tell me why, Meda?
Sir, because they are vector products, they should have direction and magnitude both.
Right, both omega is also a vector product. Your alpha is
And
also a vector product, yes. In fact, velocity is a vector, angular velocity is a vector, angular acceleration is also a vector. Therefore, first option is correct. That's just to give you an idea about angular velocity. This is the basic definition of differentiation. Okay, go to the next question. This is again from the definition. What is the time rate change of angular displacement given as
Angular velocity.
angular velocity? Absolutely. Rate of change of angular displacement is angular velocity. That's all. Right. In uniform circular motion, okay, when the particle is undergoing circular motion with a constant speed, okay, direction of velocity in uniform circular motion, first one becomes 0, is constant, is changing, none of the above.
So it keeps on changing.
Keeps on changing is correct. Absolutely right. Because at every point, how do you find the direction of the velocity, Rahil?
Tangent.
Excellent. Tangent to the
Tangent.
circle. Tangent to the circle. Yes, very good. Correct. That's the right answer there, Raj. Okay. So changing is correct. Speed is constant, but direction of velocity keeps changing. Okay. Now, guys, we will be getting disconnected shortly and we'll be connecting back on the same link, right? Please connect ASAP immediately. Okay. Just go through what we have done for a minute. We'll be connecting back shortly.